All right, this will be our last lesson in chapter 3. So we're dealing with section 3.5, parallel lines and triangles. And so postulate 3-2 says, it's a parallel postulate, and it says that through a point not on a line, okay, so through a point not on a line, there is one and only one parallel line to that given line, right? This contradicts something we saw in a Kahoot and E block. I didn't do that Kahoot and D block because of that question, and it seemed to be other faulty questions. But there was a contradiction where it said that basically this was false, right? So anytime you have a point P in this case that's not on a line, the line M in this case, then there is exactly one line that's parallel to line M through point P, is what this is saying. Okay, so if you have a point not on a line, there's one line that goes through that point that's parallel to the other line. Okay, all right. Hopefully that's pretty intuitive. 3-3 is pretty much the perpendicular equivalent. So if you have a point not on a line, right, then there's one and only one line that's perpendicular to the given line, right? And so here again we have line L, and then we have point P, and this time we're saying, okay, well, there's exactly one line that goes through point P that's perpendicular to line L. All right. All right, let's introduce some terms that we'll be using in this section. So auxiliary line, I've also heard that pronounced different ways, but auxiliary is another way. But I'll call the way I pronounce it is auxiliary, although I think I've pronounced it different ways in my life. All right, and so an auxiliary line is a line that you add to a diagram to help you in a proof, right? So now remember that the parallel postulate allows us to construct a line that's parallel to a given line, right? So that would be an example of an auxiliary line. And in that case, it would actually be a parallel auxiliary line, right? So the exterior angle of a polygon. So that's if you extend a side of any polygon, then the angle formed by the side that's not extended, and the extended side basically is an exterior angle. Okay. All right. Not to say that this side can't be extended too, right? This would be another exterior angle here, right? So the angle that's formed by an extended side that is outside of the triangle, right? So it's extended side and another side outside the triangle or outside a polygon. All right, and then remote interior angles. Okay, so now that we know what an exterior angle is, the remote angles are the angles that are not that don't form a linear pair with the exterior angles, or they're not adjacent to the exterior angles. Okay, so the non-adjacent interior angles of an exterior angle are called the remote interior angles. All right, so we'll be using those. All right, so the first theorem that we're going to prove in this lesson is theorem 3-11, triangle sum theorem. And so triangle angle sum theorem, I should say. And so the triangle angle sum theorem basically says what a lot of us already know, that the sum of the angles of a triangle is 180 degrees, right? So if we add up all the measures of the interior angles of a triangle, they would add up to 180 degrees, okay? And once again, I think we all know this, but now we're going to actually prove it, all right? So here we're given triangle ABC. And usually we start with the givens here, and I'd say given triangle ABC, but just given a triangle that doesn't really tell us any information about that triangle, right? And so it's not really something that we need to include, but you're welcome to include it. If you include it, you're not going to lose any points or anything, but it's not really something that helps us to, because we're given a triangle, so, what can we say with that? It doesn't really help us at this point, okay? So, but what we can do is draw an auxiliary line through one of the vertices of the triangle, and so we chose B in this case, and we want it to be parallel with the opposite side, right? So the opposite side of B is AC, okay? So we're going to draw a line PR through B that's parallel with AC, okay? And remember, we can do that with the parallel postulate, right? So I'm going to write step 1, draw PR, I need RR. So PR, so line PR through B that's parallel to line AC, right? Or segment AC. Okay, and the reason we can do that is the parallel postulate. All right, so now we have our auxiliary line. So now that we have parallel lines here, now we can use our parallel stuff, right? And one thing in a proof, as you see, when you get a given, or when you make a statement, that leads to certain future statements, right? So if I know two lines are parallel, then I'm going to start thinking about, hey, alternate interior, alternate exterior, same side interior, all those types of things, right, are going through my head when I get two lines to be parallel, okay, corresponding, so forth. I don't know if I said all of them, but so that's when you start to kind of get used to these proofs, you'll start to say, oh yeah, when this comes up, then these are my possibilities, right? And so we'll get to that point in a second here. But another thing we can say is, okay, we also can see from the picture that we have some linear pairs, right? We have angle 1 with angle ABR. We have angle 3 with angle CBP, okay? So we can use either of those in this proof. So let's use the last one that I mentioned. So we'll say that angle 3 and angle CBP are supplementary, right? And we know that because angles that form a linear pair are supplementary. And that's from our linear pair postulate. Okay, and remember, you can say angles that form a linear pair are supplementary. That's okay too. So you can name the postulate, or you can say what the postulate means. Okay, all right, which almost is better in some ways, right? That means you really understand what it means. All right, so now if two angles are supplementary, what does that mean? That means they add up to 180, right? So I know the measure of angle 3 plus the measure of angle CBP equals 180 degrees, right? And the reason we know that is definition of supplementary. Okay, all right. And so sometimes we want to stay away from measures. If we're trying to find like angle blank is congruent to angle blank, then I might want to just keep it in terms of just the angles themselves. But since we want to find the measures and make them equal to 180, this is probably a little more beneficial to start getting the angle measures, getting angles in terms of their measures. All right. So now we can say, okay, well, angle 1 plus angle 2 equals angle CBP, right? So basically, I want to be able to kind of break this up and get them in terms of angle 1 and 2. So we can use the angle addition postulate, right, to say that the measure of angle 1 plus the measure of angle 2 equals the measure of angle CBP. Okay, and we can say that by the angle addition postulate. All right. Okay. All right. So now we can substitute, right? We can say, okay, well, let's put this in here for CBP. So we can say, okay, well, measure of angle 1, or let's measure of angle 3 plus a measure of angle 1 plus a measure of angle 2 equals 180. And we can do that by substitution. Substitution property of equality, right? All right. Okay, so basically, just to reiterate, this, right, came from subbing this in for this, right? Since those are equal values, we can replace one with the other. So we did all that to say that 1 plus 2 plus 3 equal 180, right? Add up to 180, which was fairly intuitive because they make a straight line, right? It's not a linear pair, it's kind of like a linear triple, and we don't have a postulate or theorem for that. So it took us a little bit to just say, oh yeah, these add up to 180, right? So it seems pretty obvious, but you can see the logic that we had to include to make it technically prove that. Okay, all right. And so now we can start using our parallel line information, right? So angle 1 here, if PR is parallel to AC, then I have two transversals, right? I have this transversal and I have this transversal, right? So angle 1, the transversal is AB, right? So angle 1 would be congruent to angle A, right? Because they're alternate interior angles. So I can say angle 1 is congruent to angle A. Okay, and I can say alternate interior angles theorem, right? Okay, but at the same time, let's do the same thing with angle 3, right? What would be congruent to angle 3? You guessed it. Angle 3 is congruent to angle C, right? Because those are alternate interior. All right, so let me add this information here so we know that this is congruent to this, and we know that this is congruent to this. All right, so now we need to get these in terms of their measures. So what we need to say is, okay, well, the measure of angle 1 is equal to the measure of angle A, right? And the measure of angle 3 is equal to the measure of angle C, right? And we say that by the, saying that congruent angles have equal measure. We can say definition of congruent angles. Do it this way. Okay. All right, so now we can use some substitution because we have this equation here that says that these add up to 180, right? That 1 plus 2 plus 3 equals 180, but now instead of 1, we can put angle A, and instead of angle 3, we can put angle C, right? So what I can say, and the reason I'm doing that is because I want the angles of the triangle, right, to add up to 180. So I can say the measure of angle C plus the measure of angle A plus the measure of angle 2 equals 180, right? So C plus A plus angle 2, those all add up to 180, and we just use substitution there. All right, and we just proved that the sum of the angles of a triangle add up to 180. All right, so it was a longer proof, and we had to use an auxiliary line for the first time. And you can see, even though that was a commonly known fact that the sum of the angles of a triangle are 180, it took us to chapter 3, section 5, to where we had, the logical firepower to actually prove that, right?